Hi, this is Sonia Doucette. In this video, I'll show you how to convert between mass of a constituent element, meaning an element that makes up part of a compound, and the mass of the compound itself using two different conversion factors. The first of them is mass percent, and the second is using the ratio of moles of an element in a compound to the total moles of that compound. So what I'm going to do is do this problem in two different ways to illustrate two different ways that you can approach this using those two different conversion factors. So in the first case, I'll use mass percent as a conversion factor. So here's the problem. The plants in your garden need 1.5 grams of potassium per day to survive. The compound potassium nitrate can be used to supply your garden with potassium, which is 38.7% of potassium nitrate by mass. What mass in grams of potassium nitrate should you use or add to your garden each day so that your garden gets the desired 1.50 grams of potassium? So basically what's happening here is you can only add the potassium to your garden in the form of potassium nitrate, in the form of this compound here, because potassium by itself is actually a cation. And cations don't exist for very long on their own because they have a positive charge. And remember, things want to be neutrally charged in order to be the most stable. So calcium will bind with something else. In this case, in the compound we're looking at, it's bound with the nitrate anion. So you want to find out how much of that potassium nitrate you need to use to get 1.5 grams of the potassium cation, essentially, which is what your plants need. So what you can do approaching this using mass percent as the conversion factor is you can think about it like this. If 38.7% of the potassium nitrate is actually potassium, then if you had 100 grams of potassium nitrate, then you'd have 38.7 grams of potassium. So that's one easy way to go from percentages to masses. So there's your conversion factor right there. 100 grams of potassium nitrate for every 38.7 grams of potassium. So what your garden needs is the 1.5 grams of potassium every day, and you know that for every 38.7 grams of potassium, you have 100 grams of potassium nitrate. So all you need to do here, because the grams of potassium will cancel out and you're left with grams of potassium nitrate, which is what you want to know for this problem, that's going to leave you, when you do the math, with 3.88 grams of potassium nitrate. So this is how much potassium nitrate you'd want to add to your garden to get that 1.5 grams of potassium, which is what your plants really want. So another way to approach this problem is to use the conversion factor, where you think about how many moles of an element are in a mole of the compound. So let's start thinking about it like this. So just as before, you know that you want to add 1.5 grams of potassium to your garden. And here you can use molar mass to get potassium into moles, because if you can get potassium into moles, then you can compare the number of moles of potassium in 1 mole of potassium nitrate. So using the periodic table, you determine that there are 39.10 grams of potassium in 1 mole of potassium. And then if you just look at this compound, potassium nitrate, for every formula unit of potassium nitrate, you're going to have 1 potassium atom. So what you can say as a result of that is that for every 1 mole of potassium nitrate, you're going to have 1 mole of potassium. So now you're to moles of potassium nitrate. So you're almost there. You just need to get to grams. So moles of potassium is going to cancel, grams of potassium is going to cancel, and then you just use the molar mass of potassium nitrate, which is 101.11 grams of potassium nitrate in 1 mole of potassium nitrate to actually get to your mass of potassium nitrate. So moles of potassium nitrate will cancel out, and when you do the math there to the correct number of sig figs, you'll get 3.88 grams of potassium nitrate. So notice this is the same answer as you got before. The other way of approaching this, you also got 3.88 grams of potassium nitrate. So there are 2 different ways to approach this type of problem.